Hi, this is Mrs. Yenny, and I'm going to talk about the learning objectives or the learning goals for our next unit. What do you expect? This is a unit that will focus on probability and statistics. And for each of the investigations that you'll work through, you'll be keeping track of your learning on each of these learning goals, or your level of proficiency on each of the learning goals. So here they are, and we're going to just briefly discuss them today in this short little video. So learning goal number 1 deals with determining the probability of a dependent event. And learning goal 2, a little different, determining the probability of an independent event. And you'll understand as you work through this unit the difference between those two different types of events. Learning goal 3, you're going to interpret fractions, decimals, and percents as probabilities. In fact, every time that you give an answer as a probability, you'll give that answer in terms of fraction, decimal, and percent equivalents. Learning goal 4, you're going to find and reason with expected value, and of course you're going to end up understanding a lot about what expected value means and how it applies to a lot of real-world applications. Learning goal 5 is to determine the fairness of a game, and not just to determine if it's fair or not, but also to adjust the rules or the scoring system in order to make a game fair. Learning goal 6, you're going to understand experimental versus theoretical probability, and I'll talk about that a little bit more in just a moment. Learning goal 7, we're going to practice a little computation on the side, and what applies well with probability is some operations with fractions, so we'll be doing a little bit of review with that learning goal. And then of course learning goal 8 is the same learning goal we've had for all of our units. This is our showing your mathematical thinking learning goal, kind of our process goal. Alright, so we're going to start with talking about investigation 1. In investigation 1, we're evaluating games of chance. So the first thing that we need to understand for investigation 1 is the difference between experimental and theoretical probability. And you'll practice this after playing a couple games in this investigation, but right off the bat I want us to talk about the definition. So experimental probability is the probability that is determined through experimentation. And so that's of course the key word here, through experimentation. So for example, if we are talking about our Powerball game that we play of course at the start of every class period, and we're talking about the probability of drawing a 3. And remember, of course, in our Powerball game we have 6 tiles, and each tile has the numbers 1 through 6, each of the numbers 1 through 6 written on it. And so if we want to find the probability of a draw of 3, what we're going to do is we're going to draw several times and sort of make a data table. And that's our experimentation. It's basically just collecting data. And as we do that, we're going to find the number of times that the 3 is drawn, and we're going to divide that by the total number of trials to get our experimental probability. Now that's different than finding our theoretical probability. Theoretical probability is found by really analyzing a situation. So to analyze a situation, we need to know a little bit about what's in this container. And what we do know is that we have 1 3 on a tile that's available, and we have a total of 6 tiles. And so what that helps us to understand, of course, is the following. So let's step back a second and look at our experimental probability of drawing a 3. So here I ran a little experiment. I collected data, and that's this little data table that you see here. I've listed all of my attempts. You can see that I have 10 attempts. And then I've listed what happened on each of the draws. And as you can see, I drew a 3 times out of 10. So my experimental probability of drawing a 3 is just that, 3 out of 10 or 3/10. And of course that's 30%. Theoretical probability, again, remember, is analyzing the probability of the situation. So I know that I have 1 3 in the container out of a total of 6 tiles. So my probability of drawing a 3 theoretically, this is what we would expect to happen, is 1 out of 6 or 16 2/3%. Okay, another thing that I want to talk about as an introduction to investigation 1 is finding outcomes. And finding outcomes is really important, especially when it comes to finding the theoretical probability. You cannot accurately analyze a probability situation unless you know how many possible outcomes there are. When we talk about outcome, we're talking about a possible result. So if you think of a die, of course, and you know that there are 6 faces on a die and each face has a different number, we know then that just the simple roll of a die will have 6 possible outcomes. There's 6 possible things could result. So if we're trying to come up with how do I find all the outcomes, one of the best ways to do that is to make an organized list. And to make an organized list, we always like to start with a tree diagram. And that's what I'm going to do here with you. So you can see that I have created a spinner with 4 colors. And also in this little activity, we're going to flip a coin. So our probability game that we're going to play involves first spinning the spinner and then flipping the coin. And I want to know how many possible outcomes there are. So again, we're going to make a tree diagram. To do that, we're going to list all equally likely outcomes of a spin. And it's important that you really think about these words here, equally likely. That term is really important in probability, and it applies, of course, to how we will build our tree diagram. So as you can see on the spinner, we have 4 equally likely sections. And so when we build our tree diagram, we start by splitting it into 4 equally likely sections. And I'm labeling each of those parts by each of the colors of the spinner. The next thing we'll do is we're going to list all equally likely outcomes of a coin flip. So maybe I initially spun a green, but then I still have 2 equally likely outcomes that would result from flipping a coin, heads or tails. And the same thing is going to happen for each of the colors on the spinner. So as I do that now, you can see that I have really branched out on my tree diagram. I'm going to use that to make a list down here of all equally likely outcomes. So if you look over here, you can see my list, and I've abbreviated it, a little bit. So I have green heads and green tails, and that's what you see here as GH and GT. I've got orange heads and orange tails, OH and OT. Red heads, red tails, RH, RT. Blue heads, blue tails, blue H, BH, BT. So you can see here that I have 8 possible outcomes. Another way for us to determine how many outcomes we're going to have is just to simply look at what we're dealing with. To start with, the spinner has 4 equally likely outcomes. The coin, of course, has 2 equally likely outcomes. And if we multiply that 4 by 2, we can also get our 8. So we're expecting, of course, to get 8 equally likely outcomes. All right, and the last thing that I want to talk about before you get to work up on investigation 1 is what it means to have a fair game, because you're going to have to analyze some games that you're going to play in this investigation and determine not only if the game is fair, but also what do you do if a game is not fair. So first of all, let's just think about what it means for a game to be fair. For a game to be fair, it is a game that has every player with an equal chance of winning, or every player has an equally likely chance to win. So for example, in this diagram, you can see this boy, we're going to call him Joe. Joe has a 1 in 4 chance of winning. And this is Jane here, and she has a 3 in 4 chance of winning. So obviously Jane, with a 3 in 4, a 75% chance of winning, has a greater chance of winning than Joe with a 1 in 4, a 25% chance of winning. So obviously we can see that that game is not fair. And it doesn't matter what game we're talking about. All we need to know is that the probability shows that the game right now currently is not fair. So how do we make that fair? Well, rather than changing the game, we're going to leave the game the same. What we're going to do is we're just going to adjust the scoring to make the game fair. And that's pretty simple to do. Joe is saying here, I need 3 points per win if Jane here gets 1 point per win. And the reason that he's saying that is that if Joe gets 3 points per win and we multiply that by his chance of winning of 1 in 4, he ends up with a 3 in 4 chance of winning the game. And then we can see that that matches now Jane's chance of winning if she gets 1 point times her original 3 in 4 chance of winning. So now the game is fair. This isn't the only way you could adjust the points for scoring. Maybe Jane would like to get 2 points for every time she wins. And if that's the case, then of course you can probably calculate fairly easily then that Joe would need to get 6 points per win. All right, so that's it for sort of the introduction to Investigation 1. Feel free to watch this as many times as you need, and I hope that it helps. Thank you.